Okay, so welcome back, and hope you all had a great weekend. I certainly did, and enjoyed it quite a bit. And spring is finally here, I think. Uh, and This week, we're going to go into uh, machines that are AC driven. Last week, we went over DC driven generators and motors. And this week, starting today, we will go into alternate current. So the book that you should be using is that one, okay? AC Alternating Current Fundamentals by the same guy, Stefano Herman. All right, not the best book, but it'll have to do. All right. Okay, so DC, one of the things that we should remember, DC induction and AC induction are separate things. Okay, they're not, although they're caused by the same thing, have certain definite different properties. When we're talking about DC, we're basically saying that you're getting an electromagnet. That's constant. Okay, so when you put a DC current through that coil that surrounds a ferromagnetic material, you're producing a, uh, a magnet. Okay, that's stationary. The magnetism is there. It doesn't change because the current doesn't change, so it becomes constant. All right. What does change though is the energy that's in there. Once you put DC current through that coil generates a magnetic field. Okay, that magnetic field, and therefore a permanent magnet um, in the ferromagnetic material. That's a certain amount of energy that's stored. Okay, if you try to stop the current, if you try to stop the current, okay, you've got all that energy stored, and it's got to dissipate. All that stored energy has to go somewhere. So you have to account for that. And normally, what we do is we use a circuit using a diode and sometimes a transistor as well to regulate that. And a resistor, actually a resistor, the resistor allows the current to flow in a slower fashion. So you can basically, by using a diode to ground, okay, you can take that stored electrical energy that's in the solenoid and slowly, through the resistor, have it go to ground. So you're discharging the solenoid. Okay, and I think I gave you a picture of some. And anyway, I'm giving you several documents for you to review before you get started on the actual PowerPoint presentation for the alternators, which is today's subject. Okay, so there are a few important things for you to remember, and it's all stuff that you've already learned before. I've copied some of it and put it down as an assignment for you to review. One of them is learning about DC and AC, um, uh, DC and AC induction, how they're different, and so forth. And the other is power, because this is going to be a lot of the material here is all about the power that is generated or used up. And we know that if you have a DC circuit, the power is all measured in watts. Okay, there's no reactive power involved. So the DC all generators and DC motors all express the powers in watts. However, in AC, when you change to AC, then the alternators or generators, AC generators, and the motors have reactive power that's involved there. It's the reactive power is a power that's built up and returned, built up and returned, and cycle through because the current is alternating. You get current going in one direction, and then it comes back to the other direction. So what you store gets put back into the circuit as well. All right. So they've got information on that. So we'll start today with alternators. Okay, alternators, meaning these are the generators that generate AC current. Okay, and when they generate the current, of course, it's we've already seen how a DC generator generates AC current, and when we um, we use a commutator to uh, get to reverse to make sure that what we get out is pulsed AC, pulsed DC actually, and we can refine that so that we get a constant voltage. In this case, though, if you take a regular generator and use a couple of slip rings instead of a commutator, then you get AC. Okay, that's that simple. But there are many different types of alternators that you can buy, and that's the subject of today's lesson. So I've given you all the information. You can call me if you need me. All right, I'll be here. So good luck.